Welcome to class 9 on Vedic mathematics. Today, we will explore another technique in multiplication, specifically multiplication by a series of ones. This allows us to multiply any given number denoted as x by series consisting of ones. This type of multiplication can be done accurately and faster by using the Vedic sutra Antyorreva. It also means only the last two digits. In the sutra, every time we add the last two digits, we actually do not perform multiplication here, but however, the product can be found out by only adding the last two digits. It is highly useful as a shortcut for the quick arithmetic like multiplying by 11 or simply calculations in algebra. The applications of Antyorreva, multiplication by 11, rather than doing long multiplication, you can rapidly write down the product by summing adjacent pairs and keeping the last digits. Algebraic simplification, it helps solve elementary equations and polynomials by allowing you to focus purely on the last components of the expression. It's also used in divisibility rules. It can be utilized as a quick rule to test divisibility for numbers like 4. To multiply any 2-digit or a 3-digit number by 11, place the digits at the ends and insert the sum of the adjacent digits between them. For example, for a 2-digit number, A and B multiplied by 11, you can give the product or give the result as A, B, and in between you're going to add the numbers. So A plus B. And just in case, if A plus B is greater than or equal to 10, we are going to add the carry to the next level. And for a 3-digit number, A, B, and C, the answer would be A, C, followed by A plus B and B plus C. Again, if we have a carry, then the carry would be applied to the next level. Let's take an example to understand it. Instead of performing traditional long multiplication, the Antyorreva principle allows you to obtain the answer by adding adjacent digits while retaining the last digits. So here we have 43 times 11. So first step would be we write 4 and 3. In between, we are going to add both the numbers, which is 4 plus 3, which results in the final answer 473. Similarly, another example, 78 times 11. Write the numbers 7 and 8 at the end, and in between add 7 plus 8. Here we have a sum which is greater than 10. So we are going to add the extra digit from the tens place to the hundreds place. So the final answer is 858. Let's see another example. Here we have a 3-digit number which we are multiplying with 11. So here in the beginning we put 2 as's and 4, but in between we are going to add 2 plus 3 and 3 plus 4. The final answer is 2574. Similarly, let's see another example with 4 digits. 3574 into 11. So here the first and the last digit remain the same. So just place 3 and 4 at the beginning and the end. And in between we are going to add 3 plus 5, 5 plus 7 and 7 plus 4. So here 3, 8, 12, 11 and 4. So we have already seen that if we have more digits than the required in each place value, we are going to add those digits to the next level. So here we drop 4 as part of the final answer. 1 also will be in the final answer. However, the extra digit from the tens place will be added to the hundreds place. So 2 plus 1 is 3. And again, we have an extra digit in hundreds place. So this digit, I'm going to add it to 8. So 1 plus 8 is 9. And finally, we have 3. So the product of 3574 into 11 is 39314. This technique can be applied to numbers with any number of digits. So let's see another example wherein we have 7 digits in the multiplier and 11 is the multiplicand. So we are going to start with 8 and 7 and in between you're going to add the adjacent numbers. So 8 plus 7, 7 plus 6, 6 plus 1, 1 plus 3, 3 plus 2, 2 plus 7, and finally 7. So 8, 15, 13, 7, 4, 5, 9, 7. So we do have more digits than the required in a couple of place values. So we are going to apply the balancing technique. So 7, 9, 5, 4, 7, 3. The extra digit will be added to the next level. So 1 plus 5 is 6. And again 1 plus 8 is 9. So the final answer is 96374,597. Following this technique makes multiplying by a series of ones straightforward and efficient. Depending upon the number of ones, we can compute as follows. So here again 4 and 3 remains the same, and then in between you're going to add the adjacent numbers. So 4 plus 1, 1 plus 4, 4 plus 5, 5 plus 3, 3 plus 2, 2 plus 6, 6 plus 3, and finally 3. So this is going to be 4, 5, 5, 9, 8, 5, 8, 9, 3. The final answer is 4, 5, 5, 9, 8, 5, 8, 9, 3. Case 2, when the multiplier has fewer ones than the number of digits in the multiplicand. Let's understand with an example. So here we have 3 ones in the multiplier, whereas our multiplicand has got more digits than the multiplier. So here we start with by dropping the leftmost digit, which is 2. Then we are going to add the first 2 digits, which is 2 plus 3, followed by adding the first 3 digits, which is 2 plus 3 plus 4. Here, since we have 3 digits in the one series, so we continue by adding 3 consecutive digits at a time as you move from left to right until you reach the end of the number. So this follows by 3 plus 4 plus 1, followed by 4 plus 1 plus 3, followed by 1 plus 3 plus 4, followed by 3 plus 4, and finally 4. So now it's going to be 2, 5, 9, 8, 8, 8, followed by 7 and 4. So this is the final answer. Let's see another example. Here we have 3, 4, 2, 1, 5, 3 multiplied by 1, 1, 1. So our multiplier has got 3 ones. So we start from the left hand side or the left digit. We drop 3, followed by 3 plus 4, followed by 3 plus 4 plus 2. And since our multiplier consists of 3 ones, we're going to add 3 adjacent digits. So followed by 4 plus 2 plus 1, followed by 2 plus 1 plus 5, then 1 plus 5 plus 3, again 5 plus 3, and then finally we have 3. So this comes up to 3, 7, 9, 7, 8, 9, 8, 3. So the answer to this problem is 3, 7, 9, 7, 8, 9, 83. Let's see another example. Here we have 4 ones in our multiplier. So we start with 8, then 8 plus 9, then 8 plus 9 plus 1, and again 8 plus 9 plus 1 plus 2. Since our multiplier consists of 4 ones, we are going to add 4 adjacent numbers at any point of time. Now the next number would be 9 plus 1 plus 2 plus 7, then 1 plus 2 plus 7 plus 0, then 2 plus 7 plus 0 plus 4, 7 plus 0 plus 4 plus 1, 0 plus 4 plus 1 plus 6, 4 plus 1 plus 6 plus 5, followed by 3 digits. So 1 plus 6 plus 5, then 6 plus 5, then just 5. So now we're going to add all these numbers. We get 8 followed by 17, 18, 20, then 19, 10, 13, 12, 11, 10, 16, 12, 11, and a 5. So again, we need to apply the balancing technique so that we have one digit in one place value. So we start from 5, drop 1, add 1 to 2 to give 3, 1 to 6, 7, 1 to 1, 2, 1 to 3, 3, 1 to 3, 4, 1 to 0 is 1, 1 plus 9 is 10, so drop 0, carry 1. So 1 plus 1 is 2, 2 plus 0 is 2. Again, 2 plus 8 is 10, so carry 0. 1 plus 1 is 2, 2 plus 7 is 9, and then a 9. So the final answer to this problem is 9902014327315. In some cases, the number of ones in the multiplier is greater than the number of digits in the multiplicand. To solve such problems, we use the following formula. Number of repetitions is equal to the number of digits in the multiplier. Consisting of ones minus the number of digits in the multiplicand plus 1. Again, the number of repetitions is equal to the number of digits in the multiplier consisting of ones minus the number of digits in the multiplicand plus 1. So let's multiply 43 into 111. So it's evident that the multiplier has got 3 digits while the multiplicand has got only 2 digits. So the number of digits in the multiplier is equal to 3 and the number of digits in the multiplicand is 2. So the number of repetitions is 3 minus 2 plus 1, which is equal to 2. So therefore the process must be repeated 2 times to obtain the complete result. This formula helps us determine how many initial or the ending steps needed to be extended when the multiplier contains ones, then more ones than the number of digits in the multiplicand. So here 4 plus 3 is equal to 7. This sum will be repeated twice and the middle of the result. So the final answer would be 4 and 3, and in between we are going to repeat 7 twice. So the answer to this problem is 4773. Let's see another example. Here the number of digits in the multiplier is 6 and the number of digits in the multiplicand is 4. So by applying the formula, so 6 minus 4 plus 1, which is 3. So we have 3 repetitions. Okay, let's start solving the problem. So we start with 3 followed by 3 plus 1 followed by 3 plus 1 plus 4 followed by 3 plus 1 plus 4 plus 2, which is equal to 10. So this we are going to repeat 3 times. So 10 and 10, and then followed by 1 plus 4 plus 2, followed by 4 plus 2, and then 2. So here it is 3, 4, 8, 10, 10, 10, and then we have a 7 and 6 and 2. So since we have 2 digits in some of the place values, we just apply the balancing technique. So 2, 6, 7, 0, 1, 1, 9, 4, 3. So 3, 4, 9, 1, 1, 0, 7, 6, 2 is the final answer. So let me repeat one more time. So here we have 6 digits in the multiplier and 4 digits in the multiplicand. We apply the formula wherein we subtract the number of digits, which is 4, from the number of digits which is in the multiplier, which is 6, plus 1. So we are going to repeat the total sum, which is 3 plus 1 plus 4 plus 2, which is equal to 10, 3 times. So we start with 3, then we add 3 plus 1, followed by 3 plus 1 plus 4, and then in between we are going to add, we are going to put 3 tens, 10, 3 plus 1 plus 4 plus 2 is 10, again a 10, again a 10. And then we count down 1 plus 4 plus 2, 4 plus 2, and followed by 2. So when we solve this, after the balancing technique, we finally get 349 110762. Let's see another example. Here the number of digits in the multiplier equal to 1, 2, 3, 4, 5, 6, 7, 8. And the number of digits in the multiplicand is 3. Apply the formula. So the number of repetitions would be 8 minus 3 plus 1, which is 5, plus 1 is 6. Okay, so now we start with 4, then 4 plus 2, then 4 plus 2 plus 1. So this number 4 plus 2 plus 1 will be repeated 6 times. So this is the first repetition. So 4 plus 2 plus 1 is 7. Second time, third, 4, 5, 6 repetitions, followed by 2 plus 1, and then finally 1. So we get 4, 6, 7, 7, 7, again 7, 7, 7, 3, 1. This is the final answer for this problem. So 421 multiplied by 8 ones gives you 4, 6, 7, 7, 7, 7, 7, 7, and 3, 1. With this, we conclude today's session. Thank you for joining, and we'll continue in the next class. Thank you.